In question 2, we are to find the current I by superposition. So current I is the current flowing through the 3 ohm resistor in this branch. And we have to know what superposition means. Okay, so superposition is a very powerful technique where we zero all of the independent sources. So we have 2 independent sources here. They're the ones with the circles. So those are independent sources. And we zero them one at a time. We leave one on and then zero all the others. And then we calculate a response, which is a value for that particular circuit. Okay, and then we repeat for all of the independent sources, so all of them get a turn at being active, and then we calculate a final response as the sum of all of the individual responses from all those mini circuits that we solved. Okay, so let's do this problem and get a better idea of how to solve it. So now let's think about what zeroing a voltage source means. When we have a voltage source with 0 volts, there's no voltage drop across it, so it appears as if it's a wire. Okay, and we're going to denote that wire as a wire with a dashed circle around it to indicate that there was a zeroed voltage source there, just to keep track of it. And when we zero a current source, we have no current flowing through that branch, and that appears as an open circuit, and we're going to denote it with just a dashed line to show that the current source was there. Okay, so starting this, we're going to start by zeroing the 6 amp current source. So that's this guy right up here. Okay, it's a current source, and when we zero it, there's no current flowing, so it's as if it's an open circuit, so we've denoted it here, and the rest of the circuit stays the same. Now, there's something interesting here. We're denoting this I that we're trying to solve for with an I prime. It's just a designation that it's different than the final one, which doesn't have a prime in it. And then the second time that we repeat, we're going to call the next I an I double prime and so forth. We could call it I1 and I2, but this is just a notation thing. So what we're going to do is solve this circuit for I prime and keep track of what I prime is for our final solution. So what we can do is recognize that if we can find the total current flowing in this branch, so around this way, the total current, then we can use a current divider to find I prime. Okay, so to find the total current, what we'll need to do is find the resistance, the total resistance of the circuit, because we know that there's a 12 volt voltage source, and then if we can find the equivalent resistance of the rest of the circuit, we could find I of t by using Ohm's law as we've written here. So the current's going to be the 12 volt voltage source divided by the total resistance. And to find the total resistance, we can see that we have a 4 ohm resistor here that's in series with the parallel combination of this 1 ohm and 3 ohms in series, all in parallel with this 4 ohms. So that's what we've designated here. And then we can simplify the circuit, the analysis. 1 plus 3 is 4 ohms, and then a 4 ohms in parallel with 4 ohms gives you 2 ohms. Okay, so that's just a property of parallel resistors. If you have n parallel resistors of the same value, it's that resistance of the individual resistance divided by n. Okay, so this is a very useful thing to keep track of if you don't know it. Otherwise, you can just calculate it the normal way, which is just going to be 4 times 4 over 4 plus 4, and that's going to work out to 2. Okay. So in the end, this RT is 6 ohms, and we can just plug it back into our equation, and then we get 4 amps for the total current flowing this way. So that's going to be 4 amps. And then we can use current division. So for current division, we're going to have the current that we're interested in, which is this branch here. And we always take the other resistor, so this 4 ohms represents this 4 ohms, that's the one that goes on top, okay? And then we divide it by the total resistance of the branches, okay? And then we multiply it by the total current coming in to current divider. So then we come up with a value of 2 amps for I prime. So that's our first result. And then we're going to keep track of this so that in the end, when we get the I double prime, we're going to add those up to get our final result. So that's the first circuit, or first mini circuit that we've solved. So let's zero the other source and restore the 6 amp source. So what we're going to do is zero the 24 volt source and calculate I double prime now. Okay? So then how do we do this? I'm thinking that I would like to use node voltage. So then I can designate my reference node and label my nodes A and B, and I can do nodal analysis at A. So then going to the left, I've got VA minus VB over 1 ohms, okay? And then going down, I have VA divided by 3 ohms, okay? That's current. And then going to the right, I have minus 6 amps, okay? Because the current source is flowing into the node, okay? And that's equal to 0. So then I notice that my middle term, VA divided by 3, is actually my I double prime. Okay, so I'm just keeping track of that. Now, I'm just going to simplify it by multiplying this equation by 3 and coming up with the result of 4 VA minus 3 VB minus 18 is equal to 0. Okay. And then let's do nodal at B. Okay, so nodal at B, we have going over to the left, we have VB divided by 4. Then coming down, we have VB minus VA divided by 1 ohms. And then going down into the current source, we have plus 6 amps. And then going down the final branch, so let's say I've drawn it like that, we've got VB divided by 4 ohms. That's equal to 0. And then I'll get rid of the denominator and simplify the equation, and I get this. So then I see that I just want to solve for VA. I don't even care about VB. So if I manipulate these equations, I can solve for VA. And what I'm going to do is this. I'm going to double equation 1 and add it to equation 2. So this is equation 1 doubled on the top, okay? And then we do addition, add those, and then we get 4 VA, 0 VB, and minus 12. Okay, and then we can solve for VA, and we can find that it's 3 volts. And then we knew from earlier that I double prime was VA divided by 3 ohms, and then by solving we can find that I double prime is 3 amps. So then we're almost finished. So then what we do is combine the results by superposition, and we can add I prime plus I double prime to give the current I. So we just add up the results 2 amps, and 1 amp to give us 3 amps. So I is equal to 3 amps. So what does that mean? So that means, going back to our original circuit, we have 3 amps flowing through here. So that's what I is. And we found that by superposition. Now we could have solved this by nodal analysis, we could have solved this by mesh, and we would get the same result. So superposition is just another way of solving the circuit, and its benefit is that we can have simpler circuits to solve, perhaps a bit more work, but simpler circuits to work with.